So we're hosting the 3MT competition at Morehouse School of Medicine. So quickly, we're gonna give you the competition rules. So the 3MT competition was started at the University of Queensland. And in order to host an official competition, you must get permission from the University of Queensland. So thanks to Dr. Randall, Morehouse School of Medicine is officially able to host this competition. And we want to thank our sponsors. So the RISE program, the JEBS program are all sponsoring this competition. And we also thank Morehouse School of Medicine because our winners will go on to represent the school at the regional competition. The regional competition is a conference of Southern Graduate Schools, so that's CSGS meeting. This year, that meeting will be held on March the 1st in Tampa, Florida. Our students will win a cash prize here today. They also win a cash prize at the regional competition. And you as the audience get a chance to pick our People's Choice. So we have judges here today. They may choose a winner, but you may choose a different winner. So for the People's Choice, if you can take your phones out, your laptops, and log into www.menti.com, you will be able to vote for your favorite presenter today, or you can use the QR code and sign in. So you'll see this QR code throughout the presentation. Our judges today, Dr. Randall has helped select our judges. And so remember this competition, these students have to relay their research to an audience, a lay audience. So they have to be able to explain to you what they do and you not know anything about cancer, anything about antibiotics. So our judges today are Dr. Sarah Green, coming out of the Department of Anatomy and Pathology, Dr. Chantel Jordan, who's in our admissions office, and Dr. Adele Driss, who's coming out of the Department of Physiology. Our timekeeper today are our first year students, Amber Donning and Bethel. Sorry, Bethel, I left your name off the slide. So for the judges, they have a couple of categories there, a criteria they're judging our candidates on. So they're looking at comprehension, content, they're looking at their engagement, their communication. So they should be able to explain to you in 3 minutes or less about their research. So you won't see if they've been disqualified, but if they go over the 3 minutes, they will be disqualified. You just won't know about it. So for the rules, they have one slide. That slide cannot move. It cannot have any animation on that slide. And the presentation will start when they start talking or moving. So the timekeeper down there, as soon as the students start talking or moving, they will start the timer. So we ask you to please turn off your cell phones. Please don't make any sudden movements because it may throw the students off. Thank you. So our participants for today are our PhD students. We had 6 candidates, but today we have 5 that showed up to present to us today. Kian Preston, Kaylin Carey, Jackie Lynn, Malaysia McFadden, and Macaulay Abdullah. So I will present the students. I will give their title. That student will come to the podium. Well, they can't stand behind the podium because at the regional competition, they're standing in front of the podium. So you will see the students standing up here. You don't see the X, but they see it, okay? So don't be alarmed if they're not jumping around on the stage because they're not allowed to wear any costumes. So if they start talking about Superwoman, Superman, they cannot have on any costumes. So we're gonna get started. And our first participant is Kian Preston, Jr. He's currently in the lab of Dr. Tosini, who's in the Department of Pharmacology and Toxicology. Preston is also doing his research at the NIH at this time. So his title is Thankful for Night Vision. Preston? Yeah, you need to put it on.
Hello.
Don't start the timer yet.
Oh, it's over here. I see. If you enjoyed the colorful presentations you saw here today, then that's because the cone photoreceptors in your eye are working and doing their job. If you also, luckily Curtis Parker started around 9 o'clock this morning, so there's plenty of ambient light around. Unlike when I wake up at 2 o'clock in the morning, parched, reaching for my bedside bottle, sometimes it's empty. So that means I have to navigate a world with limited light. In these low light situations, it's the job of my rod photoreceptors to grant me night vision. The development of these photoreceptors is the job of a master gene regulator named NRL, which stands for neural retina leucine zipper protein. Hear me out. Neural, pertaining to neurons. Retina, that's the photosensitive tissue in the back of your eye that's responsible for light absorption. Leucine zipper, exactly as it sounds. It helps NRL zip together with similar proteins. So, during development, it's the job of NRL to turn these progenitor cells into rods. But during the lifetime of an organism, NRL's job is to maintain these rod structures, these rod photoreceptors. My research is involved with identifying new candidate interactors of NRL that might change or alter this regulatory function. What I've done a yeast-2 hybrid assay, and I've identified 30 candidates that can interact with NRL and maybe can elicit change. So a yeast-2 hybrid is like connecting two pieces of a puzzle to complete a circuit. Only if those two puzzle pieces connect will a light be formed. Setting NRL as one of these puzzle pieces, I screened the library of other proteins and took the ones that fit and produced the light. I selected 2 of these based on the proposed function and how often I saw it in my screen. Now, I'm validating this interaction by doing 2 methods. One is bimolecular fluorescence complementation. Hear me out. Bimolecular, 2 molecules, fluorescence, emitting light. Complementation, together. What happens is I split a fluorescent molecule, I attach one to NRL, the other to the candidate. If the 2 proteins interact, then the full fluorescent molecule comes together and we see a light. The other is co-immunoprecipitation, which is a fancy word for molecular fishing. Co-to immunoprecipitation, using antibodies to pull something down. I set NRL as my bait and see if it can catch my candidate. I set my candidate as the bait to see if it can catch NRL. This is what basic research is about. Putting together the puzzle pieces so we can see the bigger picture. My project is salient for vision and eye health because in cases where these 2 puzzle pieces don't connect, we can have a better idea of how to approach treatment. Thank you.
Thanks, Preston. I think only about 40% of us can do what you just did. So Jackie is our MD PhD student, and her title is Raising Antibiotic Resistance, Tracking the Storm. Her advisor is Dr. Emma Gluck out of MBI.
Antibiotic resistance is like rising water. If we're not actively fighting against it, one day it can overflow and flood our healthcare system. In 2016, 700,000 people died from antibiotic-resistant infections, infections that could not be treated by the antibiotics we typically use. And it's estimated that by 2050, 10 million people will die from antibiotic-resistant infections every year. Hospitals often track surveillance and tracking of antibiotic resistance through local antibiograms. And these are tables that have a list of organisms or germs that commonly cause infections. And for each germ, it shows the percentage that's resistant to various antibiotics. When hospitals create this on a yearly basis, they're able to see trends over time in how antibiotic resistance is changing. However, it doesn't show the relationships between antibiotics, where resistance to one antibiotic may be associated with resistance to another antibiotic. And sometimes changes in the relationships between antibiotics can suggest new or novel strains and germs that could turn into a storm and wreak havoc in our healthcare system. The purpose of my study is to look at antibiotic-resistant patterns in children with Staph aureus skin and soft tissue infections seen at Children's Healthcare of Atlanta, Eggleston, and Scottish Rite hospitals. and we were interested in 7 different antibiotics. We applied a method called association mining, which basically looks at all the patterns of resistance among these 7 antibiotics and identifies which patterns were present in our data set. As an example, one of the patterns we identified was resistance to clindamycin and erythromycin, which has been increasing in prevalence from 2002 to 2017. And more recently, this increase has been driven more so by the non-resistant form of staph, MSSA, than the resistant form, MRSA. Association mining, when used in addition to local antibiograms, could improve our surveillance and tracking of antibiotic resistance and warn us of any incoming storms before they arrive.
Malaysia, come on and make your way to the podium so you can get mic'd up. Okay, so we're ready. Our next participant is Malaysia McFadden. Malaysia is also coming from the Department of Microbiology, Biochemistry, and Immunology. Her advisor is Dr. Rajesh Singh. Her title today is Weeding Out Ovarian Cancer.
Weeds in my garden again this year? How can I rid weeds from my garden? Every year, approximately 20,000 women are diagnosed with ovarian cancer. And unfortunately, just like weeds, recurrence in ovarian cancer is very common, leaving women who are diagnosed with advanced ovarian cancer to face an 85% chance of recurrence after their initial chemotherapy treatment. Once ovarian cancer returns, it is then considered incurable. I find ovarian cancer to be just like these weeds of mine. I have literally tried everything. I've tried extractions, removing them directly from the ground. I even tried spraying the weeds with a liquid weed control. But this treatment was so toxic, it killed not only the weeds, but the grass as well. And can you believe, here I am once again with weeds in my garden that are now even bigger and resistant to the initial treatment. So what am I supposed to do now? Let's do some research. I found that there is a granular weed control that not only prevents the weeds from coming back, but directly targets the weeds and not the grass. We find this situation to be very similar in ovarian cancer. The initial treatment for ovarian cancer is an extraction or tumor debulking surgery, followed by a toxic chemotherapy drug treatment. This treatment usually kills both the cancer cells and the normal cells, leaving it very hard for our body to fight this disease. And just like weeds, once ovarian cancer returns, it is resistant to the initial treatment. And in this case, it is platinum resistant. So the ovarian cancer must now have a targeted treatment that directly targets the cancer cells and not the normal cells. In our lab, we use a drug nanocarrier called a PBM nanoparticle. The PBM nanoparticle is able to encapsulate both an effective chemotherapeutic drug and a non-toxic natural compound. The PBM nanoparticle is able to directly target the cancer cells by binding to the cancer cells receptors. This nanoparticle is able to, again, directly target the cancer cells and not the normal cells, overcoming the acquired resistance and inducing cell killing. This ultimately leads to survival in ovarian cancer patients. Wow, I can't believe after all these trials, errors, and hard work, I now have a weed-free and beautiful garden. And I think I just found a way to weed out ovarian cancer. Thank you.
Thanks, Malaysia. All right, so our judges are moving fast now. Okay, so our next candidate is Makali Abdullah. So Makali is currently in the Department of Pharmacology and Toxicology. So we're giving MBI a run for their money today. Okay, so his title is prostate pathology or prosthetic purpose. Dr. Shepard is his advisor.
All right. So just as you and I use our fingers to sense our environment and to respond to stimuli, so can our cells. Our cells, however, produce small finger-like projections called primary cilia. And all of the cells in our body virtually can produce primary cilia. However, only cells that are not actively dividing and in their purpose can do so. This is due to the ciliary anatomy. So, just as the knuckle on your hand anchors your finger to your hand, the basal body structure anchors the primary cilium to the membrane. This is significant because in actively dividing cells, that basal body structure will interconvert into the centrosomes, which are integral to cell division. Because one thing cannot be in two places at once, actively dividing cells typically do not have primary cilia. Now, that brings me to thinking about what kind of diseases are characterized by uncontrolled cell division. Cancers. We're specifically interested in prostate cancer due to it being the most common non-skin cancer experienced by males, and because of the severe health disparity between African American males and their white counterparts. So our question is, if we can force prostate cancer cells, which do not exhibit primary cilia, to produce primary cilia, can we slow them down? We're going to do this with the action of a drug called dexamethasone, which has been proven in other cancer models, including lung, kidney, breast, and pancreatic cancers, to force these cancer cells to produce primary cilia. We're going to see if dexamethasone can force can force prostate cancer cells to produce primary cilia. And in addition to that, we want to see if it changes anything about their activity when dividing, and if it does anything to their metastatic potential or their ability to invade or migrate to different parts of the body. By giving these cells their fingers back, we can be one step closer to putting them back into their purpose, addressing the health disparity, and being one step closer to achieving health equity. Thank you.
All right, Kaylin, come back to the podium. So I forgot to mention when I was giving the rules that the audience, you can't ask any questions. So that's why we haven't been passing the mic around. You don't get to ask any questions on the 3MT competition. Dr. Rana, you ready?
Can you hear me?
Yeah.
Okay. Woo. Well, I'm back again, yeah. Okay.
Not yet. All right, so we're gonna start again. Kaylin, your mic is on now. Testing, 1, 2.
Hello.
Okay. Okay, so Kaylin coming from Dr. Lillard's lab in microbiology, biochemistry. Her title is Ovarian Cancer Cells, All the Places You'll Go.
Ovarian cancer cells, once normal before, develop a mutation that becomes the chore. They divide and divide with no stopping guide, leaving scientists hoping they remain localized, meaning they don't spread far from where they began, but they still have a plan, figuring out ways to circumvent. So they can leave behind a chemokine trail known to stimulate the migration of cells, a trail that can attract more cells. This can lead to inflammation, which is really just immune system irritation. You know, like when you fall and scrape your leg, or when you get stung by a bee, or maybe get a virus from a flea. You see, these cells are on the go, to and fro, constantly looking for a new place to go. So in our lab, we've shown using RNA sequencing, we can extract the millions of reads that make up the facts. A read is just a small piece of the genome, our genetic code. Within, the real story will unfold. Behold, a gene, a novel thing, a little piece of information you pass on to your offspring. So in our lab, we use a network analysis. And from there, we can study genes to see their gain or loss of function, like paralysis. So we hope to find a way to look into these things one day. We want to study both high and low gene expression. In our lab, we've been able to see that CXCR5 plays a role in the Brown module, which could lead to having an effect in stage 3, affecting immunoreactivity. And we hope to show a world where these cancers have no place to go. Thank you.
So, the winner of the 3-minute thesis, I'm not sure if this has ever happened before, it may not have happened ever before, is Maisha McFadden.
So not only is she the people's choice, but she's the judge's choice. Congratulations.